logistic regression. We are not covering the ordinal logistic regression because of probably the lack of time, but we have that video in our YouTube channel. You can go through that. It is also not that difficult. Only you need to test few assumptions. And if those assumptions of ordinal logistic, they are not met, you should go with the multinomial. So multinomial is more, or rather you can say it is inclusive, because for ordinal logistic, there is something known as the assumption of proportional odds. That assumption needs to be met. That's why that's not always met. So that's why multinomial is more commonly done as compared to the proportional, that ordinal logistic regression. That's why we decided to cover multinomial first without covering the ordinal logistic regression. So in till now, what have you seen in binomial? The term is binomial. Why the term is binomial? Yes, anyone?
Only two categories are there.
Very good. Only two categories of
Variable.
which variable?
Maybe that is gender, male or female.
Dependent variable.
No,
Dependent.
there are two terminology. There is a equal to sign. There's a variable which is towards the left side, and there's variable towards the right side.
Outcome.
But
Outcome
yes,
variable.
you have to be very careful, because many times when you don't pay attention, you get confused. Like, see, because more than one level, in 3 level, that is there in the binomial also, but that is in the context of the independent variable. Here the term binomial or multinomial or ordinal.
That's why I want to like that.
Akanksha, can you mute? I think let me, Mohit, Akanksha, I think I can hear you people. Can you mute yourself?
Yes, ma'am, they have muted.
Okay. So you can see that this term, specifically whether it is multinomial, whether it is binomial, or whether it is ordinal, that is in context of which variable? Independent or dependent? Yes?
Dependent variable outcome.
Yes, yes. So you have to remember it very, very, very carefully and importantly, that the term which we say, that is only with regard to the dependent variable. So what do you understand by multinomial?
More than two categories.
Yes.
Three or
more than two categories. It can be three. I think somewhere someone has put the mic as a unmuted probably.
Ma'am, I'll check.
Okay. Can you do take care of this part, Haripriya? Okay.
Yes, ma'am. Yes, ma'am.
So multinomial is in context of the various levels of a dependent variable. So now you know that there is something known as the ordinal variable, and there is something known as the nominal variable. We have discussed this yesterday also. So what is the difference between the two? Like if I give you an example, if I say that student level he has like first level, second level, and third level. If I say this, and if I say like students are belonging to basically 3 states, Bihar, UP, and Rajasthan. So now I have categorized the medical students into 3 levels of 2 different variables. What is the difference between the first, which is the grade 1, 2, and 3, and the second, where I have assigned them a state like belonging from Bihar, UP, or Rajasthan? Yes, any one of you? Can you unmute and answer or type in the chat box?
And first one is the ordinal,
second is nominal.
Yes, so nominal, you can interchange the order. What do I mean by interchange? Like if you are giving one value to the this thing Bihar, you can write 2 to UP and 3 to Rajasthan. Similarly, if you can write 1 to Rajasthan, 2 to Bihar, and 3 to UP, it is not going to make any difference. That means change of order is not going to make any difference. Whereas in case of a ordinal, you cannot write 1 to a person who is in grade 3 and 3 to a person who has stood first, something like that, because there is a order. Similar concept is here in the multinomial logistic regression also. So in binomial, we have seen that the outcome has got 2 levels. But what to do if we have got more than 2 levels? So now see this slide for a few seconds. You can see in the first variable is the choice of contraception. And the various categories are OCP, copper T, and medroxyprogesterone acetate. The second one is pain, which has been categorized as mild, moderate, severe. Third is the preferred method of follow-up. You want to do a follow-up by telephone, in person, by mail. Fourth is the vaccination status, not vaccinated, partially vaccinated, fully vaccinated. Fifth is a tumor grade, grade 1, 2, 3, and 4. And sixth is the preferred way of teaching method. You are teaching with PowerPoint, chalk and talk, or with interactive board. So in all these variables, what can you find out first? It is not a like category, more than 2 categories there. So like in case of choice of contraception, everywhere you can see there are 3 categories except for tumor grade, which is a 4 category. So can you tell in which variable there is a natural order?
Pain, ma'am, pain. Tumor
Yes.
grade.
Pain,
Tumor
tumor
grade.
grade. Anything else? What about the vaccination status?
Ma'am, it will come in the nominal category.
But why, if you are seeing that if your achieve, it depends. If you are like treating it as a fully vaccinated, is like in order it is more than non-vaccinated. If you're taking the outcome as a positive outcome. So you can treat it either as a nominal or you can treat it as an ordinal also. It depends. Like you can have it is up to you. So if like maybe if I'm doing something where I want to make a model of this as a fully vaccinated, partially and not vaccinated, I may treat it as an ordinal also and I may treat it as a nominal also. So that's okay. So if a variable has got more than 2 categories of levels, then it is called a polytomous variable. Polytomous means more than 2 levels. So you have to look for the categories or levels in the dependent variable. If there is no order, it is multinomial. If there is an order, it is ordinal. So how to do such analysis when the dependent variable has multi-level, more than 2 levels? So you will see that many times what people say that club them and make 2 categories or levels and run binomial. Like you can do for if there are 3 categories of OCP, copper T, and means MD. This Mirena is like I think it's not. Just take it as a medroxyprogesterone acetate or copper T 1 type 375 versus copper T Mirena type. Then you can club OCP versus copper T and MD medroxyprogesterone acetate. Then this grade also tumor grade you can club. There are 4 grade, but you don't know, or maybe you don't want to do the multinomial. Then what you can do? You can club these 2 grade together, like grade 1 and 2 together, grade 3 and grade 4 together. Similarly, you can club like mild in one and moderate and severe together, or you can club in person versus telephonic by email together. So you can, for ordinal, you can also do like if there are 3, 0 and 1, 2, then you can club 0 and 1 into one category and you can take 2 as a separately. Or like if there are 4 levels of pain, none, mild, moderate and severe, you can club none or mild together and moderate and severe together. But what is the disadvantage of doing the dichotomization? If you do such dichotomization, what is the disadvantage? Yes? So basically you will be losing the detail because initially you had 4 categories. So if you merge them, you will not be able to know the value of each category separately, the odds ratio. That's why generally it is not recommended that you should club it when you perform a modeling or a logistic regression. So we have just seen that this is not recommended, or what you can do, that you can run those many, rather what I can say, I think it's, sorry. Next, now if you can't do that, what is the next simple approach? So the next simple approach is you can develop those many models. If the outcome has K levels, then you can develop K models. How you can do that? So you can convert the multinomial variables to many binomial variables. Like you can convert in-person versus telephonic plus email, one binomial you can run like this. Again, you can do like email versus in-person and telephonic. This will be another binomial category. And the third binomial category will be like telephonic versus email plus in-person. So like in more generalized form, if you have got 3 levels A, B, and C, you can merge first these two together and you can run a binomial with A versus B and C together. You can merge A and B together. You can run a binomial with C versus A and B. And again, you can run a binomial with B versus C and A. So this is, if you have attended our session on ANOVA, or if you know the ANOVA as such also before, like even if you have not attended, then you know in ANOVA also we have discussed this concept that you have got 3 categories and you are trying to see the value, the mean value, the difference of mean value in 3 different categories. So you can do a multiple independent sample t-test also. So what that independent, but why can't you, why you should not do that in the multiple independent sample t-test? Why you should do ANOVA? Because that increases the error. Similar concept you will see here also. So here you have developed 3 models. So you have run 3 separate binomial. So now can you appreciate, so in binomial, how in the logistic regression, how the result, like basically what is a quantitative way through which we convert the this group membership? So basically we estimate the probability. We have discussed this yesterday, that based on permutations and combinations, and the technique which is being used is the maximum likelihood technique, through which we calculate the probability. And based on that probability, whether the value of probability is more than equal to 0.5, we call that the outcome has happened. And if the value is less than 0.5, we say that the no outcome is there. So that is based on the calculated probability. And you have seen in JAMOVI also, there is an option of predicted probability. If you click that, you have you can see a known probability against each of these group membership, whether the membership it has assigned, like in this case, in the previous one, whether the surgery has been cancelled or surgery was done. So similarly here also you can see that you have got 3 models, but what will happen? So you will have one equation that will give outcome probability of this outcome A, taking the reference B and C together. In the second model, it will give you the probability of outcome C as compared with taking the reference of A and B together. And in the third one, it will give you an outcome of B, probability of B, C, taking the reference of A and C together. So can you appreciate that addition of all these probability value of individual will be more than 1? Because if you calculate 3 different equations, and if you add the probability of all these 3, you will see, you can from mathematical equation, it is you will see that the value of probability will be more than 1. But we know that the value of probability cannot be more than 1. And why this is there? So because when we run a separate binomial regression of a multinomial variable, it results in a total probability of more than 1, because it increases the standard error of estimation, which is the beta. That's why the total probability becomes more than 1. And this can be resolved using multinomial logistic regression. So what happens in multinomial logistic regression? Like in this example, the multinomial logistic regression, there are three options: in-person follow-up versus telephonic versus email follow-up. So there are three levels. So multinomial logistic regression assign one level as reference. So here, like in JAMOVI, you have seen that you can change the reference levels also. So this assign one category as a reference level and then make model for remaining levels for the outcome variable. And the choice of reference is arbitrary, unlike ordinal, because in ordinal, you have to take the lowest category as a reference. But in this case, even you can change the reference level depending on your research question. So for k levels of multinomial logistic regression, it makes k minus 1 model. That means if you have got 3 levels of a category, then it makes 2 model. It makes 2 model. So let's see this multinomial logistic regression. So if you have understood the binomial, all the commands and options are very much similar to the binomial logistic regression. So this is the question and the data set. So the case scenario is a researcher is interested in finding out the preferred course of action for treating illness that run in families. So he surveyed a target area, asking the locals questions about their age, their gender, place of residence, socioeconomic situation, and level of education. And he also asked about the desired course of treatment. So based on that, he wants to know, like, what are the odds of choosing an allopathic therapy over a homeopathic treatment, or what are the odds of choosing an Ayurvedic treatment over a homeopathic treatment. So he has taken a dependent variable, which was the choice of treatment. So choice of treatment, it could be allopathy, it could be homeopathy, and it could be Ayurvedic treatment. And he wants to see, like, what are the odds of choosing a allopathic over a homeopathy, or what are the odds of choosing a Ayurvedic treatment over a homeopathic treatment. So if we come to the data set, I'll just delete all this, all, and remove. So all the results are now gone. And now you can see the variables. So I'll explain the variables first. You can see here, number of variables are less. This is the gender. If you double click it, again, you can see male and female. Male is 0 and female is 1. Then if you like keep on moving arrow like this is the age, which is continuous variable. Then you can see the residence, again, rural and urban. You can see socioeconomic status, low, middle, and high. And then education, illiterate and literate. And then you can see we have taken the preferred mode of treatment. So we have taken like homeopathy, Ayurvedic, and allopathy. That's it. So these many variables we have taken. Now coming to the analysis. So my question is, I have to see the odds of a preference of allopathic treatment over homeopathic and Ayurvedic over homeopathic. So I'll go to the analysis. Again, I'll come to this regression. And in regression, you can see there is an option of binomial. We have discussed that. And there's an option of multinomial with the n outcome. So if you click this, you will see that this window will appear. And here you can see it is again interface is very much similar to the binomial logistic regression. So you have to move the independent variable here. Sorry, dependent variable here. It's written also, and then covariates and factors into these boxes. Now, the way we have done in the binary logistic, that first we see the unadjusted odds, and then we like p-value, and then you do the adjusted one. Similarly, you have to do here also. So you have like before that in the model, this thing. In the model fit, you can click on this overall model test, and in omnibus test, you can click on this likelihood tests, and then odds ratio because you need unadjusted odds. Here, like we have done for the survival, you don't have any other option. Like even if it is there, we have not explored that in single click you like there you were getting the both unadjusted and adjusted together. But here we have not explored it till yet. So what we recommend that you should go like this, that first you do one by one and keep on duplicating the result. How you can duplicate the result? So I will move this preferred treatment here in the dependent variable. And then I will first use this gender. Click this gender and move this to this box. And then you can see that p-value. So p-value is significant, both the likelihood ratio and this is the unadjusted odds. So you can see the unadjusted odds there remember we discussed that for k levels, it makes k minus 1 model. So you can see it is making 2 models here. So one will be for Ayurvedic as compared to homeopathy, and second will be allopathic as compared to homeopathy, because it is taking homeopathy as a reference level. If you wish to take any other reference level, you can change it from here. So if you see the reference level, it is giving the odds in females as compared to male. We have discussed this yesterday also, that whatever is written first, it will give odds in that with reference of the second. And you can check it from here also. So what is the odds here? So p-value, I'm just checking now whether you should include this in model or not. So p-value is significant, so I will include this. You can duplicate this result. How to? Because you need this result. In SPSS, what happens? The result doesn't disappear. So that is like in the single document. But here in JAMOVI, it is a dynamic output. The moment you will make this variable into this box, the result will disappear. So what you can do, you can right click this. You can select it all probably, and then go to analysis and you can duplicate. So if you duplicate, this result will be there. It will move up and it will be saved. Now what you can do, you can come to this part and then again you can move this back. So the upper one which you have duplicated, that gray one, the color will change. The active sheet will be white in color, whereas whatever you have saved, that will be gray one. So that is saved. Now you can move this age here and you can see the p-value. So p-value, you can see that it is significant here. So you will include this in model. Again, what you can do, analysis, and you can duplicate. So again, this will be saved. So you can see here, you have saved this one also, and you have saved this one also. Now, moving this here, you can again do the similar thing for residence. So I can check for the residence. So residence also, you can see that it is significant. So right now I'm not focusing much on the odds ratio because I know that I am only deciding which variable to take in my final model, depending on the sample size. So my sample size, if I check with for the sample size, you can go to exploration, descriptive, and you can see the preferred mode and you can see the frequency table. So in the frequency table, you will see that the total count is 220. So now it has been split into 3. So now that can be, I have got enough sample size and I can take those many variables into my model. So this was, we were doing till here, residence. Again, duplicate this analysis, go to analysis and duplicate. Then again, you move this back here, residence. Now come to the socioeconomic status. And you see the value of p-value of socioeconomic status. So it is again significant. So what I'll do, I'll again go to the analysis and duplicate. I'll move this back here and then I'll go with this education. I'll see the p-value. P-value is 0.13. So again, it is up till 0.2. So I will use this. So this way, this is the same. It is not difficult, Dr. Muhammad, and it is not time. The only thing, because you are not habituated to see this. That's the only difference. It is not difficult because a person who is seeing binary logistic for the first time, he might also think the way you are thinking for multinomial. So it is just because you are seeing it maybe less number of times. The more number of times you see, it will be as convenient as you have seen it for the binomial. The only difference is you have got two models separately because you have got 3 levels here. So then again, you can duplicate it for this also. And now you can see all the results, above results are saved. So if you have to make a separate table also using these unadjusted odds, you can write that. So I'll move this back. Now I have planned to take all the variables in my final model because all are significant. So now what I'll do, I'll move this gender here, age into this, and then all these variables together into this. So now you will have a final multinomial, this one. So now you can see, we will focus one by one. First, see the reference level. If you wish to change these reference level, you can change like we have done earlier. In the here in the multinomial logistic, if you see, you don't have to test for assumptions. It's not there. You only have this model fit statistics, like you have seen for the multinomial binary logistic, and then model coefficient. So this is the way, and then what you can do. First, I will focus on the first part. So let's focus first on the first model, which is the Ayurvedic versus homeopathy. So it is just think that it is like the binomial. You are telling the odds of preferring the Ayurvedic. So you will see there are two levels, Ayurvedic and homeopathy. So what I'm telling, if the gender is if the odds ratio is 1.45 times. So how I will interpret it? I will write that the odds of preferring Ayurvedic over homeopathic was 1.45 times in female as compared to male. Did you get it? There are two comparisons. So odds of preferring Ayurvedic versus homeopathy was 2 times more in female as compared to male. Similarly, if you have to compare this, you have to write that the odds of preferring Ayurvedic versus homeopathy was 0.5 times in urban as compared to rural. That means it was less in rural. Rural people were not going for Ayurvedic more as compared to homeopathy. Similarly, for socioeconomic status also, you can compare the odds ratio. Since these are not significant, if you see the p-value, none of the p-value is significant here in this 0.2, 0.8, 0.9. Whereas if you see the second one, so now I will focus on this one. Allopathy as compared to homeopathy. So you can see that here age is significant, gender is not significant. So this is significant, this is significant, and in socioeconomic status, high versus low, this is significant. So you can comment on these. Again, you can say that with 1 year of age, increasing age, the odds of preferring the allopathy over homeopathy was 0.01, was odds is 0.9 times. Similarly, you can say that for odds of preferring allopathy over homeopathy, you can see now in urban area. So in urban area, people were preferring allopathy more as compared to the rural area. And urban area, the people were preferring allopathic more as compared to the homeopathy. Similarly, if you see high, so people were preferring more allopathic treatment in the high socioeconomic status. So that's how you can have a table where similarly you can copy paste this table, and you can here you can add a column of unadjusted odds ratio, and you can show that too. So if I see the result and this thing, so this is the table which we have just copy pasted from the JAMOVI, both the two model, and then you can write like based on the this logistic regression, multinomial logistic regressions, we can say that the model containing the full set of predictor represents a significant important improvement in the fit relative to the null model, and based on the likelihood. So is there any reason for mentioning the assumption, not mentioning the assumptions in the this thing? So we tried to find out this, like why we don't test for assumptions here. But again, we are still exploring this, Dr. Muhammad. This even I am not sure why we are not testing the assumptions the way we have done in the binomial. And you will see that in JAMOVI, that option is not there. Like the way you have seen for the, even the calculated, if you do this in SPSS, you will see that there, you will see the probability. So I'll show for one basic concept how this probability of 1 is getting broken into the 3 probability. I'll show that in SPSS. First, let me explain this result, because this like the calculated probability you have seen in the binomial, you don't see that option in JAMOVI here. So I'll show you that. So you can see that I was reading the result. So all predictors, so you can just see that we have written all those which we have just discussed now. So now coming to that, we have a SPSS sheet also. So if I open this.
Ma'am, I have a question.
Yes.
Ma'am, can you please go to the JAMOVI result?
Yes, Pragya.
And suppose in Ayurvedic and homeopathic model, the first model, suppose the gender is significant. Suppose.
What is significant?
The gender.
Okay.
Suppose it is 0.01.
Mm-hmm.
And the odds ratio is 1.45.
Mm-hmm.
Okay. But in the allopathic and homeopathic model, so the p-value is significant and odds ratio is 1.8. So what will be the interpretations of these two?
You just want to say that it is significant, right, in both the cases?
Yes, both the cases.
So you will write that in this case, since the reference is male in both the case and preference of this Ayurvedic, so you can write that here they are preferring Ayurvedic treatment more as compared to homeopathy. So you can have that odds of having this 1.45 times of preferring Ayurvedic more as compared to homeopathy. And here, because it is not like they are not, that's what I will answer this question. Let me show you the SPSS, because there you will see that it is not like that they are not preferring homeopathy or they are not preferring Ayurvedic, but the one probability is broken into 3 parts, right? And then based on the highest probability, it assigns that particular group. I'll just show you, then probably you will understand this in a better way. So this is the SPSS. So this is the same data set. So now this is the estimated probability. Can you see the preferred treatment is 1. If I go to the variable view and if I see the preferred treatment. So 0 is for homeopathy, 1 is for Ayurvedic, and 2 is for allopathy. Okay. So now if you come to this data view, you will see that this, can you see the predicted probability? All of you, please add these 3 values. Please add 0.61 plus 0.37 plus 0.03. Yes, all of you, please do that. One. So you will see that this was for the predicted probability. This is the highest. So you will see that all these 3 probability, that's what we were discussing, that what it does in binary logistic, since there were only 2 levels, so the predicted probability was like getting broken into 2 parts. Here the predicted probability, since there are 3 levels, it is getting broken into 3 parts. So there we have decided that if a particular probability is more than 0.5, more than equal to 0.5, we will assign that particular group to a outcome happen. What is happening here? That here we take the largest one. So which is the largest one? Largest is 0.61. So that's why we have given the probability like here as 0.61 and 0 was for the homeopathy. So the group which predicted group membership is of 0, homeopathy, because this was for the first group probability and the probability for homeopathy is highest. So that's why we have assigned it to a group of homeopathy. Similarly, you see this one. Maybe let's focus on this one, this case. Now tell me which has got the highest probability, which of the 3? It is 0.66. So you can see here that 0.66 is the taken probability is 0.66. And the group membership has been assigned, the predicted one is of 2. And 2 was what? Allopathy. 0 was homeopathy, 1 was Ayurvedic, and 2 was allopathic. So how in multinomial it decides? It takes the maximum probability. It is not based on any cutoff. So 1 is getting broken into 3 probability, and that highest probability, it is falling into which category, it assigns that group membership. Did you get it? Have you understood this part? Then I'll go back to that table where Pragya just asked the 2 different gender in 2 different model. Have you understood this?
Ma'am, how to calculate this estimate and the group membership? Similarly, in the SPSS.
You cannot calculate it. The software calculates it actually. Again, that is based on likelihood estimation and that is running in the background. So in JAMOVI, that option is not there. That's why we have to take help of SPSS. Maybe it will come because JAMOVI is like it is open source. So people are adding module every day and every time it is getting updated. Maybe in the latest 1 or 2 or 3 months after you may find this option in JAMOVI also. But currently it is not there. So just to understand, because for giving the result, you don't need this. But just to make you understand, we have shown this, like how this is getting broken into 3 and how it takes the largest part and assigns that group membership. Is it okay, Dr. Muhammad? Okay, I think you people are finding it a little difficult. So now again, going back to this table where Pragya was asking. So now you can understand that there are 2 odds here. This is one odd. Well, And I assume that this is significant. And this is again 1 odds. So the interpretation will be the same. Like you have to write that the odds of preferring Ayurvedic versus homeopathy was 1.4 times in the male as compared to the female. So there will be 2 different odds because 1 odds will be for Ayurvedic and 1 odds will be for the allopathy, taking the homeopathy as a reference. And regarding that assumptions, we have discussed that it is not, maybe let me check with the SPSS. I don't think SPSS, I don't think there are few assumptions are there. So if you go to analyze multinomial, you can go with the model. So here you can write preferred way of treatment. Here you have to like write the reference level. So like in my case, homeopathy was a reference. So you can write the first category and then you can give like age here and covariate in, sorry, these 3 together. Yes, assumption that will be goodness of it, that is there also. Model, if you say, you don't have to. Statistics, again gives you pseudo R square, likelihood ratios test, goodness of it, you can click. Information criteria like AIC and VIC, and cell probabilities, what we were discussing. But no need, like SPSS, we are not telling you. You can go like for simple one, that will be the, you know, you don't have that option here actually for checking. Okay. So that's how you have to run this multinomial logistic regression, and you have to express it the way we have shown you. Okay. Complete silence. If it is okay, then we can go to the breakout room and practice.